My presentation, my interest in the field is the bridges and infrastructures. I have done a lot of special type of infrastructures in my life, in my career, which engulf a lot of entertainment structures. My deliberation will be on that, on those fields only. Now, whenever we do entertainment structures, entertainment related like stadiums, like auditoriums, even I will show you one bridge which you can call it as for use for a people's amusement. So, there are some functional requirement and some aesthetic requirements for all these type of structures wherever it is built. And these amusement functional requirement, there are in stadiums there are requirements from various authorities. Auditorium there are capacities, viewing system, then what is the air conditioning system, lot of MEP systems are all involved. And second thing is that nowadays the projects in our field, the time frame is very stiff. So with that stiff time frame, with the very, when I started my career, I have seen that project is being built, you know, second Hooghly Bridge was built for 20 years. So that type of time frame no one gives nowadays. So nowadays time is short, so you have to find out a system where we have to build in the within the time. Like national games, all stadiums, every 2 years there is a national game in India, and within 2 years, lot of cities are holding these national games, and they have to build the stadia within the 2 years. So within 2 years means they have to build the stadiums, at least 10, 12 stadiums. I am involved in 2 such projects, and we have to very fast track, we have to find out a system. So where use of steel can be very suitable for fast construction and for better quality control, and some precasting. We cannot avoid totally concrete. Somewhere concrete is required, so precasting of the concrete and the steel construction is the best way to reduce the time of construction. Now, general design, this you all know that there are wind load, earthquake loads and dead loads. The durability and ductility is very important nowadays. Most of the structure I will show it is in highest peak ground acceleration area. So PGA is very high. Then ductility requirement is very, very important. You have to think of the joint details from the ductility point of view. And wherever you are working, you have to see the material and manpower, from where, what is the skilled manpower, what Mr. Mukherjee was telling in a very relevant point, that where you are working, what skilled manpower you are getting, and what material you are very easily available. Sometimes I am telling you in Mumbai, you will see a lot of steel construction in eastern region, because steel is plenty available nearby. But if I was in Mumbai for last 6 years, so I have seen that most of the construction is on concrete. But because the steel is not easily available, but you will happy to know that Mumbai Trans-Harbour Link are being constructed of steel. It is over the sea, the bridge is over the sea. It is orthotropic deck concept. It was being built. The package 1, package 2, there are 3 packages are there. I was involved on that one of the package in that project. So there is made of steel, but not Indian steel. There is a JICA funded project, so there I am not going into those details. Now I am just, because of time short, I am making it a little faster. This is one project of 33rd National Games in Guwahati, Assam. So you know this is a high seismic area, and this is a Sarusujai complex. There is a place called Sarusujai in Guwahati, and beside National Highway. There are 3 stadiums has been built. So 3 stadiums has been built, 1, 2, 3, and I can show you this is a main athletic stadium. Partially, because second thing is that money is a concern. See, people are talking, we are talking about life cycle cost. I agree with Mr. Mukherjee that even bridges we have done the life cycle cost. Life cycle cost is shown as cheaper than overall cost. But what happens when it's in India, it is a tendering system. Lowest bidder will get the job. So if you do for steel and if you do for concrete, the main cost, the initial cost in steel is always higher. Now if you go for a steel instead of concrete, you will lose the job. So people are going for concrete because of that reason, unless tender specifies to do steel. There are projects which is specified for steel, like railway long span bridges. We are doing number of more than 100-meter span bridges of railway. Even MG Setu Patna is making, old Setu has been demolished and new bridge is coming up, which is also of steel. There are still railway is going for steel construction, except small span bridges. And wherever competing bidding is there, both the options are open. People are going for concrete because of the cost, initial cost. People will not look into while giving the project, people will not look into the life cycle cost. So that has to come from the implementation agency that you use steel. So this stadium is a 28-meter cantilever truss, a girder, lattice box girder, cantilever. This cantilever is there a pointer? There is no pointer, no? Okay. Huh? So this is a 28-meter long truss without any front column or intermediate columns. We have made it of steel structure. See, steel structure is very good for long span structures. Now this is a long 28-meter truss, was built with 2.75 meter depth and 1 meter wide. This is made of steel, and also, and why we have okay. So this is 28-meter long, and this is around 2.75 meter depth and 1 meter wide box type steel truss, and there is no columns in front. What we have done, because of the overturning moment, we have made this is wider Y column, and we made one tension side, one compression side bolting there. So this is a athletic stadium of 30,000 capacity, and I have already told about this, the lattice girder of 2.75 meter depth and 1 meter wide, and span to depth ratio, span to deflection is 325, and sheet is, for aesthetic reason, we have used galvalume or zinc alum sheets. This is the type of the detail. One side is taking tension, one side is taking compression. That type of detail has been followed. You can see the construction stage photograph. This is after construction. This is another indoor stadium. This is the architectural view. Now here also span is very large. This is 60-meter span, and this truss is around 3 meter depth with 1 meter wide box. Now all this box has been used because there are a lot of, in these stadiums, lot of utility pipings, lot of lighting systems, internal special lightings, all are fixed on this truss, and all cables, etc. There is a catway on every truss. People can go inside and walk inside. That's why the height has been made so large. So this is also another example of large span steel construction with stadium. And what we have done, that in all these cases, the concrete, this column is concrete, the roof is, because of large span, made of steel, not concrete, and this is a parallel activity. When concrete is being under construction, steel has been fabricated and then erected as soon as column is ready. This is also 2,000 capacity stadium with roof girder of 3 meter depth and 1 meter wide, 61 meter span. You can see that during construction how it looks. One truss is erected, how aesthetically it was built. This is the after construction. This is another stadium which is called Rajiv Gandhi Indoor Stadium in the same project. This was a double curvature roof, not other whatever I have shown you all single curvature. This is a double curvature roof with a rhino type of nose in the front and the back. So this is followed by the architectural requirement of rhino is Assam's the main the sanctuary Manos, where the rhino is the main animal. So considering this, I will just speak about the structural system. What we have done to do that, we have made a spine arch of 150 meter span at the central. So that spine arch is springing from the foundation and to the one side of foundation to the other side of foundation, which is supported on batter piles, driven piles, batter piles and some vertical piles. And then all these other members, other sides, these are all latticed girders, a span varying from 19 meter to 40 meter. This was supported on this arch. So arch was built first, and then when it is coming here, all deflection has been measured, and that matched the deflection each and every trusses, so that there has not been a mismatch while erecting. Now this is the arch view, 150-meter span with 3.5-meter depth and 2.5-meter wide. This is also indoor stadium with 2,500 capacity. Now if you see after erection how it looks, this is the spine arch, and these are the lateral other arches, other trusses. These are all truss or lattice girder, whatever box type or lattice girder, they are all getting connected. Here is a transfer girder is there, which is connected to, because there is a lot of jumble up of all the trusses are coming. So there is a cross member is there to hold the things. If you see the panoramic view of this constructed roof, now this is the foundation part of it. Is a very large foundation. Actually, this 150-meter span arch has a very high lateral loads at the base. So to take care of the lateral load, the batter piles and others are even used. This is the completed stadium. Now this National Games project has also won first prize from Consulting Engineers Association of India for excellence in the project dealing, project execution and project engineering. Now this is a unique stadium. This is the Velodrome in Commonwealth Games. This was constructed in a very short time. The engineer, contractor, the designer, the client was Central Public Works Department, PWD, CPWD, all has to work together, and the approving authority was IIT Delhi. So we have to very fast working, and probably the time is fixed for the Commonwealth Games, and this is the job. There are a number of, you know that the Commonwealth Games number of stadia has been built. This is the last stadia which was awarded to the contractor and to the consultant. Both as the last job has been given. This is the last project, and we have the shortest time to develop this, to build this. So what we have done a model that the whole roof is, if I explain here, whole roof is supported on these two arches. There are two arches is inclined inside, and these two arches, from there are hangers, and hangers are holding, this is also double curvature kind of a hat, and this whole inside there are lattice girders. Whole lattice girders are hung from these hangers, and these loads from the truss is transferred to the arch, and arch is finally transferred to the foundation. So almost, if I am not long back, something around 800-900 ton horizontal force we are getting at the arch base, and around here because this is near Jamuna river is near, soil is very poor, we have to drive around 1.5 meter dia pile. We cannot do driven pile, so we have to go for a board consistency to vertical piles. Around 40 piles are there below the arch, so it's a huge load being transferred to the base. So this is the model, this is the arch, these are the two arches, and these are the trusses supporting through these hangers. So arch span is around 150 meter, 146 meter, and height of 38.7. So this is the geometry of the structure. Now if you see inside, there is no column inside. So whatever stadium or whatever I am showing, there is no column inside, and the viewing is totally free. This side is around 100 meter, and lengthwise around almost 150 meter. So there is no column inside. Whole structure is very long span and supported from the roof. If you see the construction stage, now first arch was built, then one by one the trusses has been built and connected by the hangers. And here also the sequence of construction, the deflection and the matching of the structure with the hangers has been checked through calculations and at site, and it has exactly matched to the millimeter level. I am the construction is very skilled. The contractor who has done very skilled way, and the calculation and gone at so much at par. We are so happy while looking into their construction. This is the arch constructed. You can see this trusses have started building. Trusses have started building here. If you see more trusses has been built. This is the section of the truss 1.2 meter by 1.5 meter. Very thin trusses are, inside trusses are 100 meter span. So only depth of 1.5 meter by 1.2 meter wide, because of possible only 5 intermediate support from the arch through hangers. You can see other views. This is some detailings. I am not deliberating much more detail on this. This is the truss base details. Now if you see the view and the sheeting has started, this one is sheeting has started. This is also double layer sheeting with insulation inside. This is the foundation. This is also a huge foundation of the arch. This is the base plate of the arch. This is the kind of a bolt box we call it normally. Now this project was also by INSDAG, already told by Carol, that Stup has got the first prize for innovative structures in 2011-12, and CPWD executive engineer who was in charge of the project, he has also got an award of excellence from the CPWD Director General. Now this is the very enlightening word. The Delhi Velodrome is absolutely marvelous facility of highest standard, and probably would only be surpassed by the Beijing Olympic Velodrome, built at the cost of $215 million. It was told by Ray Godkin, who is the Honorary Vice President of International Cycling Federation. Unless he gives permission, he homologuing the velodrome, no international competition can held in a velodrome structure. So he is the main man, Roy Godkin. He is so impressed with that, he has given this, passed this comment. And if you see that Beijing Velodrome is $215 million, Delhi Velodrome was built in only $34 million. Now I am showing you some structures in and around nearby. There I can show you number of structures. We have done the Noida Stadium. We are doing now Air Force Museum in Delhi, which are all space structures and very complicated structures, all with steel. So if you go on showing, it will take long time. So I am showing recent structures. These are all whatever I have shown already built. But this is under construction. You know that there is a 2,400-seater Kolkata auditorium at Alipur, which is probably known as Dhanodhanno Stadium, probably later. I am not sure exact the name. This is you can see the shape of the stadium is like a conch, what we call it in Bengali shankho. So, and this whole outside frame, whole frame was steel. And this is a totally three-dimensional, there are bidirectional, a lot of geometry is very complicated. And the layout of purlins for holding the sheeting, layout of every frame, if you see that these are the frames, these are the frames. Now every frame has a different dimensions, different radius, different geometry. Because of this, conch is not is a tapering, in center is maximum diameter, at the edge it is lower diameter, in the tail is a lower diameter, and that is also not tapering uniformly. So that geometry is a very complex issue, and we have completed the engineering. That's why I am showing we have completed the engineering, and it was NVCC project. NVCC is building here, and IIT Kharagpur was the approving authority. We have got all approvals of the all drawings. This is the front view. These are, if you see that these are the steel structures. These are the steel frames. These radial frames are steel frames, and laterally going, there is a rafter in that. Then the sheeting, purlin, etc. will be coming. I am not going every detail. This is around 200 meter long, around 50-60 meter height. Width is also around 70 meter. The maximum dimension I am telling. This is actually the frame structure. What was built in the this was not done in, this was done in ETAB model. So this is the steel part of it. There are concrete columns where rooms etc. are there, and these are the steel total. These are the frames. This will be very difficult to with this view, and you can imagine that it is so difficult to design, and we have completed it, and very soon, maybe I don't know exact date of completion. So it will be completed, and you will be able to get a very nice structure in Kolkata, Alipur area. This is another bridge which was also, I will say it's a bridge, but this is not a vehicular bridge. It is a pedestrian. At the same time, this is an amusement park also. This is a, normally bridges are any 7 meter, 8 meter, 10 meter, 14 meter. 14 meter is 7.8 is the 2 lane. So multiple of that it is being built. But it is a pedestrian bridge. Width is 20-25 meter. So people can go inside, can sit and see the enjoy the river. See, it is built. It is under construction at Gujarat, at over Gujarat, Ahmedabad, over Sabarmati. There is a Sabarmati river. If you go, there are bank developments. There's a lower promenade and upper promenades. They're all, you can walk there, their boating facilities are there. So they are building between the Ellis Bridge and the Sardar Bridge, there are two bacular bridges there. They are building this type of bridge which is full of steel construction. Full of steel construction, there is nothing there except the walkway, everything. Walkway also we tried to make of timber, but because of durability and others, we could not. And I tried to make it very high grade of steel, because here stress variation which causes fatigue is not that high, because this live load is, dead load is always permanent, and live load is basically not that high as far as road bridge or railway bridges is concerned. But I could not get that E5 more than E410 steel. We could not able to, we have talked to number of, here steel forum is there. So I am telling you that please start manufacturing those high grade steels, so that we can, somewhere we can use. Wherever fatigue requirement is there, wherever serviceability requirement is there, Mr. Mukherjee already told, we cannot use, I agree, we are also saying so. But wherever possible, we should be allowed to do, because that will give aesthetically much better structure. We have to unnecessarily go on increasing the diameter of the pipes here because of lower grade of steel. But if you go for a sleeker steel, it will look much better. So this is under, if you see that inside is people are walking here, there are sitting arrangement, plantation, everything is there. So it is more of a amusement, small, I will not say park, but amusement walkway. So has been under construction, already awarded to one contractor. Both the projects is P&R Infra Projects is doing the construction, and our design is over. IIT Madras, Dr. Arul Vayachandan is involved in approval. So this is the status of this project. Now with using steel, there are a number of advantages has been told by Mr. Mukherjee, but I want to add some few points. Steel is a material which is a durable, and first type is ductile. It's a very ductile material, and it helps in seismic zones where the ductile material is most important, we look into ductile detailing for steel, for seismic zones. And second thing is that, next point is the steel is a lighter, very light compared to the concrete. Concrete dimensions are very heavy, so steel dimensions are very thin, so it is lighter and transfers less force in the foundation, and it attracts less seismic force, because seismic force, earthquake force is the function of the gravity load. So that attracts less seismic force. That is also advantage in developing the foundation. Structural behavior is very predictable. The joints, everything, whatever you design. Concrete, what happens, these joints has become rigid joints. Behavior sometimes is not very predictable. So steel, it is very predictable, and whatever we have seen, that whatever we do calculations, deflection, etc., and it is exactly matching. I have one experience, giving you one example, that I was doing cable stayed bridge of concrete construction and cable stayed bridge of steel construction. In the case of steel construction, the deflection control while erection of the cable while I am doing, in case of steel construction, whatever we are matching much closer to the calculated values. Concrete, it is not, because concrete do the batching, the density gets changed, the creep factor gets changed, the elasticity, modulus of elasticity, we have done this, we have done every batching check for elasticity, modulus of elasticity, it is varying the different modulus of elasticity, we are getting in a different batching. So one batch, it is some elasticity modulus, one batch, it is something, the density is little bit varying. So whole thing, whatever I am assuming 2.5 density in concrete, or 5000 root over FCK is the E value, but that is not exactly matching at site while doing. But in steel, my material property is assured, the density is assured, the E value is assured. So all those limit conditions are much more better managed at steel construction. Obviously, congested area. We have a few months back, we are deliberating on steel bridges, and where we have showed that steel bridges, you can see in Kolkata there are a number of flyovers made of steel, even piers are made of steel, girders of steel, composite construction. So now plenty of composite construction is being done in Kolkata with all those flyovers, Acharya Prafulla Chandra APC Road flyover, or Ma flyover, or Park Street flyover, whatever it is. Lock Gate, there is another flyover. So city congested area, the steel construction is easier because of less traffic diversion, less obstruction. You can do the erection of the girder at the night, so that will help you. Second thing is that I have shown you some long span structures. We have already built in Bhairav Bridge steel with 105 meter span. We are doing 120 meter span bridge in northeast, also 120 meter span in MG Setu, which is also steel. So the steel is very suitable for long span construction and much easy to handle in long span construction with proper erection schemes. So that is a very advantage from the steel as a use as a long span construction. Obviously, I have shown you some photographs that aesthetics and the architecture and the beauty of the structures can be achieved with steel construction very easily. So I am not saying concrete is not absolutely not possible, but steel is also for with a long span time frame, we can do it in a very short time, much faster. So all those, compared to that, steel is very suitable material for use in this type of long span structures and entertainment structures, also long span bridges. Thank you.